This video will explain how to solve simultaneous equations by graphing. These are also known as systems of equations, and so we're going to be solving for a point that makes both equations true. Now, what's nice about graphing is you actually see the solution. So if you can graph two lines, the solution is where the two lines intersect. And so we have these two equations here. Now, this is one strategy in order to graph, and that would be to fill out tables of values and then plot those points. There's other strategies to graph lines as well, such as plotting the y-intercept first and then using the slope to count over and figure out where the other points are. So either strategy works, but I personally like the tables because it's just a quick process and you can usually get the information you need. Now, sometimes you might not choose values close enough to the solution, and so you might need to extend your graph and get a larger piece of graph paper. You'll notice on the slide we have a very small 5 by 5 grid because the solution happens to fit on there, but you might need more space than that for other problems. So what I'm going to do is worry about graphing this first line. And so using the table method, I'm basically using substitution. So these are my inputs and this is my rule. So I need to figure out what the outputs are. So if I plug in 0 for x, I would get 2 times 0 minus 2 is my output. Well, we know 2 times or 0 times anything is 0. So this output is negative 2. And then I continue, so I'm going to plug in 1 this time. So then I get 2 minus 2. Well, that's 0. And then now I'm going to plug in 2. So that's 4 minus 2, which is 2. And so there's my output. So now I have these ordered pairs. So x comma y, that's going to be a point. So 0, negative 2, 1, 0, and 2, 2. Those are my 3 points. Now digitally, this is going to be a little bit harder for me to plot. So I'm going to go ahead and continue my line just so I have more accurate points. I'm going to use the slope now. I'm going to go up 2 over 1. Okay, down 2 over 1 over here. So there's just a few more points off my table, and then I'm going to do my best to connect these. When you're working on ALEKS, you have tools to ensure that your lines are straight, and so that should help a little bit with your graph. I'm going to change colors and I'm going to go ahead and do this second equation. This one I can do mentally. It's a little bit easier of a rule. So the output is found when you take x and add 1. So 0 plus 1 is 1, 1 plus 1 is 2, and 2 plus 1 is 3. So now I have these 3 points to plot. 0, 1, 1, 2, 2, 3. And I'm going to go ahead and continue plotting my points. So I can go this way, and then I can also go this way. And actually right there, right here is where we're going to find our solution. So the solution is the ordered pair that makes both equations true. Graphically, you're going to physically see where the 2 points intersect. And so I have to read those coordinates. That is at 3, 4. So x equals 3 and y equals 4. And just like any other method, we're going to go ahead and check. And the way I check is I plug in the x and the y into both of these equations. So that's my solution, but just to check and make sure I'm correct, do the graphing errors, hand drawing errors could occur. I'm going to plug in. So I'm going to take 4 equals 2 times 3 minus 2. I want to see if that's true. and that's a 4. So 2 times 3 is 6 minus 2. Does that equal to 4? Yes. So 4 is 6 minus 2, so the first one works. And now I'm going to check the second one. Is 4 equal to 3 plus 1? It sure is. So it works for both statements. 3 and 4 works for both statements, so I know 3, 4 is the correct solution. This is how you solve a system through graphing.